Unit 4, we're going to be starting with Chapter 6.3, so we remain in Chapter 6. It's a little bit strange, but what we're going to start with is vectors. So the idea is you're still going to be using your trig functions and trig skills to help you identify triangles and help you to identify certain things that are going on with vectors. So keep that in mind as we move into this vector section. The objectives for this unit are going to strictly be just knowing the vocabulary and being able to use vocabulary and certain pieces to this. There are a lot of vocab words, which is why I did include that study guide, and what you're just going to want to look for is adding in whatever I have in green. So 6.3 is dealing with vectors and the introduction to that, and our vocabulary is going to start with what we call a directed line segment. So sometimes lines aren't enough to represent a certain quantity. Sometimes those quantities also have direction. We have certain things in life that need direction and quantity, such as velocity. A 60 degree or a 60 mile per hour wind that's blowing north is going to be different and have different effects in certain situations than a 60 degree mile per hour wind blowing south. Okay, so that's an idea of where we have a quantity and direction. Right, what we do also have are what we call the initial point and the terminating point. So think of initial as the start and then the terminating as a terminal, or it's the end. So what we do is we notate it with just this PQ arrow, where P is the start, Q would be the end. Alright, so a vector now is going to be a set of all directed line segments. So keep in mind, I didn't do this in the best of orders, so I'm going to kind of scroll down here. So I apologize for that. But what we have is a standard position vector. So a vector is going to be the collection of these types of directed line segments of a certain direction and length, and it starts at an origin. So how we notate these vectors is by this, what we call component form, and the reason why we call that is because it gives the vector in terms of a horizontal and in terms of a vertical component. So if I were to sketch out that 3, 4 as I have had that in standard position, what we're looking at really is it could be any origin. So I could start here and go over 1, 2, 3. There's my horizontal movement, and then go up 1, 2, 3, 4, as indicated by 3, 4 in that those triangular brackets, and there would be my vector v. However, I could have also started here, okay, and this, if I go over 3, and then up 1, 2, 3, 4, this also could be my vector v. Okay, it doesn't matter where you draw it. This here is my new origin, technically, because there's my 0, 0 amount, and I went over 3, up 4, just like I went over 3, up 4 here. So there, both of these vectors would be represented with that component form. Alright, so double bar lines, you're going to see that referenced a lot. That's just going to represent what we call a magnitude, and so here a magnitude is just the quantity of that vector. So it's like that 60 miles per hour. Okay, what we're going to be doing then is representing 60 miles per hour with a certain length, and that's going to be its magnitude. Lowercase letters, that's what we use. So if you ever see something like little v and it's bolded, you know for sure we're talking about a vector. Alright, so calculations. Now that we know this component form, what we're going to want to do is be able to calculate these vectors. So, for example, we're going to add them, or we're going to do various things with them. So the first place to start is to let a vector have the initial point. We're going to call it p sub 1, p sub 2. Now this is the same thing as just x sub 1, comma y sub 1, because again, we're talking points, which are places on the coordinate grid. So x, comma y. But we're just going to be specific in saying that this is my start. These are going to be my x sub 2, comma y sub 2. So all of these could be interchanged, like for example, q sub 1 would be the same thing as x sub 2 minus p sub 1, which would be minus x sub 1. So what you can see here is to find a component form of a vector that starts here and ends here. All we're doing is we're subtracting the two x values. And hopefully that makes sense, because what we were trying to figure out was the x component, so how much over from a place were we working with, and how much up or down were we working with as well. And so you would hopefully see that it makes sense that we're taking q sub 2, which aligns with y sub 2, minus y sub 1. Okay, here we're going to find that magnitude, so in other words, the length of our vector. If we're looking at 2 points, what we're doing is we're basically finding the distance formula, which you'll see here. These are my x values subtracted and squared, plus the y values subtracted and squared. So one thing that I want you to note is this length right here is right here. And this length is right here. Okay, so we're basically just taking the length squared plus the y length squared equals, and then square rooted equals the total length, or the magnitude. So we are going to do an example of that. So here is a sketch of what I have going on. In example number 7, we were asked to find the magnitude and then the component form. So this right here is going to be the point, negative 1, comma 5. This point right here is going to be 15, comma 12. Okay, so you can't really see, but these are actually truly those points, as I sketched on one of the programs that we're going to be working with for these. So what we need to do first is find the component form. Component form. So hopefully it makes sense that, hey, I need to find how much over and how much up I had to go in order to get from here, the start, to this end. So it should make sense then that we're going to take our 15 minus, and then our x value here, 15 minus negative 1, because that's our x value here, sorry. And so then the y values, to figure out what is the change in the y values, well, this one was at height 12, this one is at height 5, so 12 minus 5 is going to make up that difference of that height. So when we do this, we're going to get 16, comma 7, and then hopefully you would see that, yeah, we went over 16 and up 7 from this initial start, which we're considering an origin. Okay, so again, what we did just use, we used this formula up here. We just took our x values and subtracted those, and then we took our y values and subtracted those. Okay. So now we also need to find the magnitude. So I'm going to go down to this picture again. If we were trying to find magnitude, well, we're trying to find the length of this. So hopefully you see that right triangle happening, where you would just say, hey, I'm taking a squared plus b squared equals c squared. And that would in turn lead to 16 squared plus, and then the 7 squared equals c square rooted, if we did both sides, so equals c. So that's what we're trying to find. And again, what I want you to kind of note is we would be using that same formula as take our x values and subtract them. So our 15 minus negative 1, that would be this. Okay, so 15 minus negative 1 squared plus, and then our y values, our q sub 2 minus our p sub 2, the second values of our q and then our p, so q, p, so 12 minus 5 squared, and then square rooted, and so you can see we got the very same thing as the Pythagorean theorem. That's where the distance formula comes from, the Pythagorean theorem. So when you do that, we're going to get, it's not the prettiest of numbers, but c is approximately 17.46. Okay, and I don't know what units we're in, or c is equal to the square root of 305. Alright, so we have a few things with vector operations going on. So vector operations, this is going to kind of continue with the calculations, but if you ever try to add a u plus a v vector, so two different vectors, what we are going to be doing is putting this vector right on top of this vector. I am going to sketch this, and we're going to be sketching these in GeoGebra so that it will be a little bit cleaner looking, but I'm going to do the best that I can. For number 19, what we are going to be looking for is adding a u plus v. So that's what it's asking us to do. And we're going to use this operation right here, and I'll show you why in a second. When we add vectors, we add them head to butt, or butt to head. So the idea is when we do go over 2, 1, so over 2, up 1, that's this vector right here. And then what we're going to go over is 1, 2, 3, and then up 1, so it's going to be looking something like that. And so you can't really tell, but the slope is slightly different. 1's over 2 up 1, and then this thing right here is going to be our resultant vector. So we're trying to add up these two to see what is your overall vector, and that's going to be right here. So what I want you to see is what we're going to have to total up are the x values, okay, or otherwise u sub 1 and v sub 1, so the first values of your u and the v. So we have 2, 3, comma, or 2 plus 3, comma, and then we're going to be adding the second values, so 1 and 1. And what you can see there is, yeah, we just added up the total of the y values. So we have 5, comma, 2. Alright. We also have a scalar multiplier operation, and what that is when you ever have a number outside of a vector, so let's say u is equal to u1 comma u2 as our component form, you would just take that k and kind of distribute it to each one of those pieces. So I'm going to look at this b here, and we actually don't have any subtraction, but what I can do is I can rewrite this as u plus negative 1 times our v. So if I wanted to, I could go ahead and take my u value, which is the 2 comma 1, okay, and then plus negative 1 times the 3 comma 1. What we can do is take the 2 comma 1, and this is where we're going to use that scalar. We're just going to take that negative 1 and bring it in to every single thing in that component form. So now what we have is, let's add up the first values. So 2 plus negative 3, comma, and then 1 plus negative 1. So here we have that as negative 1, comma, 0. So what I do want you to consider is if we did go, I'm going to draw another sketch here, and if we did go over 2 and then up 1, okay, and then here we had plus negative 3 comma negative 1. So here I would go back 1, 2, 3, and then I would go down 1. So if you did draw that vector right there, then yeah, from this origin or from that beginning point, I did get a vector of negative 1 comma 0. Alright. I'm going to go ahead and say this is a video long enough. We'll finish up this later.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!